find the angle between the lines. So L1 is x equals 2 minus 3t, and y equals minus 1 plus t, and L2 is x equals 1 plus 2s, and y equals minus 4 plus 3s. So looking at those lines, you can see they're both two-dimensional lines. The principles that we're going to use, you can quite easily use them in 3D as well. There's no problem at all, but these particular lines are 2D lines, plus the equations are expressed in parametric form. Right, so to find an angle between two vectors, you may remember you use this, or you start from this formula, which is a dot b equals the modulus of a times the modulus of b times cos of the angle between them, right? So this is when you've got two vectors, okay? So just sticking with that, that would mean cos of the angle, cos theta, would be a dot b over the modulus of a times the modulus of b. And also, if you wanted to guarantee an acute angle, or more accurately, a non-obtuse angle, you could say cos theta equals the modulus of a dot b over the modulus of a times the modulus of b, right? So that's when you've got two vectors. Now, when you're finding the angle between two lines, you use the direction vector as the two vectors. So literally you just do this, but you use the two direction vectors. So I've got the two lines in parametric form, so I'm just going to change that to a vector equation, and then we can easily see the direction vector. So L1, you have xy, it's only in 2 dimensions, equals the position vector to get to the line, so that's the bit without the t's. So x is 2 minus 3t, and y is minus 1 plus t. So the position vector to get to a point on the line is 2 minus 1, and then it's plus t, and then it's the bits that multiply the t's. So x is 2 minus 3t, and y is minus 1 plus t, so minus 1 plus 1t. Okay, so we're going to use this vector as our, we can call that a actually. We'll call that the vector a. For L2, xy equals the position vector to get to the line. So we're going to 1 plus 2s, we take the 1. Y is minus 4 plus 3s, we take the minus 4. So then it's plus s. And then we have 2s for x and 3s for y. Okay, so this vector 2, 3, that is going to be vector b. So we just use the two direction vectors, right? So to then use this formula, we're going to need a dot b, and we're going to need the magnitude of a, and we're going to need the magnitude of b. So a dot b equals, we said a was minus 3, 1, minus 3, 1 dotted with 2, 3. So that is minus 3 times 2 plus 1 times 3. So that equals minus 3 times 2 is minus 6. 1 times 3 is 3. Minus 6 plus 3 is minus 3. That's a dot b. Then we need the magnitude of a. So magnitude of a equals the square root of 3 squared plus 1 squared plus 1 squared. So that is the square root of 9 plus 1, which is root 10. The magnitude of b equals the square root of 2 squared plus 3 squared equals the square root of, well, 2 squared is 4, 3 squared is 9, 4 plus 9 is 13. Okay, so now we have cos theta equals, and remember, if we want to get an acute angle, or I mean it could be 0 or 90 I guess, but if we want to make sure we get something that's not obtuse, and to be fair, it didn't ask me for an acute angle, so it's not that important, but basically this is negative, the dot product a dot b is negative, so if we just put that in here, as in if we use a dot b over the magnitude of a times the magnitude of b, we will get an obtuse answer. If we want an acute answer, which generally you do, I'm just going to use the absolute value of -3. So I'm going to call that 3 over, in fact, I might, just to show the examiner that I know what I'm doing, I'm going to write the square, the absolute value of -3 over root 10 root 13. Okay, so I'm just going to write that. So now theta equals, I'm just going to go straight for theta. So I need inverse cos of, it's 3 over root 10 root 13. So root 10, we could just write root 130, but I'll do it sort of properly. Root 13 and that gives me an answer of 74.7 degrees. If I want that in radians, I could divide by 180 times by pi. Times it by pi, remember 3 significant figures equals 1.30 radians. Rads. Okay, so to find the angle between two lines, get the direction vectors and do exactly what you would do to find the angle between two vectors. If you want it to be acute, the easiest way of doing it, well, maybe not the easiest way, but one way is to take the absolute value of the dot product instead of the dot product of the two direction vectors. The other way would just be to proceed as normal doing this, and if you get an obtuse angle, take away from 180, it'll do exactly the same thing.